solve this radical equation. We have this radical equation, the square root of quantity x plus 5 plus square root of quantity 20 minus x equals 7. So we're going to use properties of algebra to solve this equation. First of all, what we have is these radicals. What do we do to eliminate radicals? What we're going to do is raise this left side of the equation to a power, and we're going to square both sides of the equation. In squaring both sides of the equation, what we're going to do is use the pattern of binomial expansion. So first of all, I write this 1, 1, 1, and then we have this 1, 2, 1, which means that we're going to have this square root of, let me just write this x plus 5 plus square root of 20 minus x, and we're going to square this whole left side. Now, one thing you have to be careful about is you just can't square both of these elements separately. You have to square the whole expression. And so what we have is this first term here, square root of quantity x plus 5. That's going to be square root of quantity x plus 5 squared. And then we're going to have, and we have the pattern 1, 2, 1. That means we're going to have 2 times both of these terms. So 2 times square root of quantity x plus 5 times square root of quantity 20 minus x is equal to, well, let's see, hang on a second, plus square root of quantity 20 minus x squared is equal to 7 squared. So that's how we square both sides of this equation. And what happens for this square root of quantity x plus 5 squared, we're left with x plus 5. And then we have, I'm going to write plus 2 square root of x plus 5 square root of 20 minus x. And then we have plus the square root and square here cancel out. So we have plus 20 minus x equals 7 squared, which is 49. So what we're going to do is combine the like terms, and we have x minus x, these will cancel, and then we have 5 plus 20. So we're going to have left over 2 times quantity x plus 5 times square root of 20 minus x. Then we have plus 25 is equal to 49. And we subtract 25 from both sides of the equation. So we get 2 times quantity x plus 5 times quantity 20 minus x. And we have, on the right side, we have 49 minus 25, which is 24. Now we're going to divide by both sides by 2. And when we do that, we have square root of quantity x plus 5 times quantity 20 minus x is equal to 12. Now, after all this work, we still have radicals, and we didn't get rid of the radicals. But we're going to persist here and do the same thing we did when we started out. We're going to square both sides of this equation. And when we do that, that leaves us with x plus 5 squared times square root of 20 minus x squared. And on the right side, we have 12 squared, which is 144. And now what we're going to do is these squareds cancel out, square roots and squared cancel out each other. So we have quantity x plus 5 times quantity 20 minus x is equal to 144. And I'm going to come over here. I'm going to bring this up here with this arrow. So what we have is, I'm just going to rewrite this. X plus 5, quantity 20 minus x is equal to 144. And so what we do is we use the distributive property of algebra and multiply these each together. So we can do it like this. Sure, you've seen this before. Another thing you can do is you can use a box method like this and multiply x plus 5 by 20 minus x, and so you get 20x, and then you have 5 times 20, which is 100. You have x times x, which is negative x squared, and you have 5 times negative x, which is negative 5x. And so what we're going to have left over here is negative x squared. We have 20x minus 5x, which will be plus 15x, and we have plus 100 is equal to 144. Now, what we're going to do is make this left side of the equation equal to 0. And to do that, we're going to add x squared, subtract 15x, subtract 100, and do the same thing on the right side of the equation. We have plus x squared minus 15x minus 100. And then on the left side, everything cancels, and we're left with 0 equals, we have x squared, and then we have negative 15x, or minus 15x, and then we have 144 minus 100, which is going to be 44. So now what we're going to try to do is solve this quadratic equation by factoring. If this equation is not factorable, we'd be left completing the square or using the quadratic formula. But often these things will be factorable, so let's go ahead and try this out. So we have the factors of x squared are going to be x and x. And then we are looking for two numbers, and we're going to have a negative times a negative because our middle term is negative. So we want two numbers that add up to 15 but multiplied together equal 44. So what are the factors of 44? Well, 2 and 22. Now if we put 2 and 22 here, we would get negative 24. That wouldn't work out. How about 4 and 11? So 4 and 11. And we can see this works out because when we multiply negative 4 times x, we get negative 4x. We multiply negative 11 by x, we get negative 11x, which equals negative 15x. And so what we have here is we use the zero factor property to make this equation true. X minus 4 is equal to 0, and also x minus 11 is equal to 0. And then solving each equation, x is equal to 4, and x is equal to 11. And if we substitute 4 and 11, 4 back into the original equation, we will see that it works out. And if we substitute 11 back in to the original equation, we see that it also works out. So both of these, x equals 4 and x equals 11, are solutions to the original equation. Thanks for being here. I hope this has been helpful. Take care.